OzGIS holds all its geographic information in a structure. So for example, this is a map of the lower electorate. There was a by-election here in 1982, and we did some maps of the electorate at that time. And in particular, we actually just had a paper map, and I actually sat down and digitized this map at the time. To do that, it was a case of putting the paper map on a digitizing table, and then you trace the map around and you go click, 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 all the way around the boundaries, and then store the information. Now the thing about digitizing in this way is you soon discover that you never want to do it again. However, bear with me, the procedure is as follows. Let me show you. In particular, the important things are the endpoints of the lines. So I can put the segments up here. Okay, and we'll put map and so the endpoints of the lines are the important thing, and these are the so-called control points. So the first thing you do when you digitize is you digitize all the endpoints, and then you very carefully start at the endpoint of each line and work around and store it and so on until you've done all the lines on the map. You also store the names of the zones on each side of the map, and then afterwards you can form a hierarchy within the data, which is the lines and then the polygons made up of those lines. Now the thing about the lines is they're a string of XY coordinates, and also stored as part of those lines are the name of the zone on the left and the zone on the right. Once you've done that, you can actually string all these polygons together and form the hierarchy. So let me show you that in a moment. But the thing is, why do you want to do this? One of the problems at the moment is the vast majority of data that's available are in shape format. You can download it from the various census bureaus, but all they give you are the polygons. Now this is fine if all you want to do is just display some simple choropleth maps, except that one thing you want to do is thin the data. And thinning the data to make it display faster and to make the file smaller involves dropping points along here, and so you end up just with an approximate lines to replace the highly detailed ones. When you do that on a polygon basis, the problem is you can drop out these special control points where the lines meet, and when you do that you end up with gaps between the polygons and so-called slivers, and it doesn't look very nice. However, you can get around this, and let me show you how. So for example, I've got some data for New Zealand territory authorities, which I've downloaded from Stats New Zealand, and I've got some census data as the usual comma delimited spreadsheets, and I've also got some downloaded shapefiles, which are the territory authorities for 2017, and it's a clipped, slightly smaller format, I believe. However, to get the data in, it's the usual thing. You do a preparation, an import our geographic files. In this case, it's a shapefile. So we're going to input the file, and we're going to select the shapefile, which is the clipped one here, and then you've got a parameter file, which is the database file, and once again it's called the same thing. The name of the output file, we'll just keep it as same as the input, and it's New Zealand territory authorities 2017. Okay. Now the usual procedure when you're putting in a shapefile, you want the name to use of the, in this case, the territory authorities, and in goes the data, and it's in there as polygons. So for example, we can do a map of this in the usual way, the zones, using an attribute data and the file that we've just put in, and there we've got polygons available in that map. Now if we want to thin this data and cut the size of it down sensibly, we can apply it. We need the line segments. Now one thing we can do is we can actually extract the line segments from those polygons, and we can assume, I think, that they've been digitized properly. So input from our file, we just input, and we'll give it a name, so we'll call it let's just call it New Zealand Territory Authority extracted segs. So, okay, and now we're going through and we're comparing every polygon with every other polygon, and looking at where the polygons match along common boundaries and pulling the segments out. I'll just suspend this. Okay, so it's compared all the polygons, and now we're writing our output file. So it's extracted. Okay. Now we've got our line segments there. We can simplify them. So here we go. We've got our New Zealand extracted file. We just extracted the segments and called extracted and thinned. Now when you thin data, you think about how many pixels it's going to sit on the screen. So it's about 1,000 across, and away we go. Extracted, now it's been thinned. Now if we want to have a look at what we got there, we can display our polygons. Now our polygons were the original input data. Okay, yes, we'll draw our polygon boundaries, and there we go. And now let's overlay on that the line segments from our thinned line. Okay, thinned. There we're putting our thin lines on top, and perhaps have a bit of a look at some of this data here. So perhaps we'll have a look down in some of this sort of interesting looking area down the Marlborough Sounds. And what you'll see is the lines for the thinned data are sort of jagged at this low resolution, and compared to the original polygons, which had a lot more fine details. However, this is fine when you're displaying at a higher resolution. Now what we can do now is we can go up and we can do some further preparation. We can now take those thinned lines, and we can build them up into a new geographic file, and we can actually, using the thinned data, we can actually build it up into a zones thing. So here's, we'll give it a name, thinned and built. some information for tolerance of joining things. And what we're doing now is we're taking all those thin lines and we're building them up into a hierarchy up into the corresponding zones. Okay, now we can go and do another map if we want to. Same thing now, we're using the attribute data we had before, and now we use our thinned and built geographic file, and we're back and we've got a map again. Now what have we actually got? Let's have a look at say an interesting sort of area again around Auckland. Now when we zoom up, you can see it starts looking a little bit jagged. So that was the thing about when you were thinning, you were asked how many pixels across you wanted. And if you're going to display zoom up areas, then you want to perhaps a high resolution, or you may want to do separate files and extract areas into different files and do them at different resolutions so you can expand them up as is appropriate. Now, when we do the building process of starting from the segments and building up into the polygons, there's a couple of things happen. First of all, we're talking about named zones, and all the segments that make up the polygons have got the names on each side of the segment, and there's a special name for when it's outside the map. Now when you build up, you build segments into polygons, but there can be multiple polygons within a zone. So here off the coast and off Auckland, you can see all the islands, which are all separate polygons, but there's several of these polygons can be within the same zone. You can also have polygons that are actually inside a map. So if you've got obviously lakes, then you can have a lake that appears inside a zone, and the lake may itself have islands inside it, which could have lakes could have islands, which could have lakes, which could have islands. So you've got a whole hierarchy of polygons, and the building process works out what the order of these polygons is. Because when you display, you want to display all your base level polygons first, and then any lakes second because they overlay it, and then any islands within those lakes third, and so on. Now the building process actually stores a hierarchy, but it also stores polygons as well, purely because when you display, you want to display polygons and you want to put them up as fast as possible. The process also stores points within each polygon. So we've seen this before. You can overlay names, for example. Thin built, open that, and using your text again, we can put up all our names. And as you can see, Auckland here has got lots and lots of polygons. All these islands are also a polygon part of the Auckland zone. So why do we do this? Well, first of all, as you've seen, for thinning works quite well because you don't always maintain the special points where the lines finish, so you don't get these sort of slivers appearing between the lines. But a more important thing is you can start amalgamating zones. So let's just go back the whole file, and let's take the overlay off. Okay, we don't really want that overlay, I don't think. Remove the names overlay. Here we go. Now, What you can do is amalgamate. So for example, if you're interested in defining, say, sales territories or regions of some sort, you can select them here, and after you've selected them, you can form the territory up by throwing away the internal lines. And OzGIS has got facilities for doing this, and we'll show you that in some later video.